The U.S. Air Force has just dropped a bombshell that's left the world reeling: the unveiling of the much-rumored SR-72 Darkstar in Jerusalem. This isn't just another aircraft. It's a game-changer poised to revolutionize aerial warfare with cutting-edge technology and blistering hypersonic speed. As the successor to the legendary SR-71, the fastest and most lethal aircraft ever built, the Darkstar is set to surpass even the wildest expectations with its unprecedented capabilities. The SR-71 was already an icon, pushing the boundaries of speed and stealth. But the SR-72 is about to rewrite the rulebook entirely. With advancements that seem straight out of a sci-fi movie, this aircraft promises not just to match, but to eclipse the feats of its predecessor. So, what are these jaw-dropping features that make the Darkstar a technological marvel? And could it truly be more advanced than the legendary Blackbird? In today's video, we're breaking down everything you need to know about the SR-72 Darkstar, from its incredible capabilities to the mind-blowing tech that powers it. Strap in, because this is the future of aerial dominance, and it's about to take the world by storm. A legend in the sky. The SR-71 Blackbird wasn't just fast, it was revolutionary. Built by Lockheed's Skunk Works division, this high-speed, high-altitude spy plane could soar at over Mach 3, making it nearly untouchable by enemy defenses. Developed in the 1960s under a veil of secrecy, the SR-71 was the brainchild of aerospace engineer Clarence Kelly Johnson. Drawing inspiration from its predecessor, the A-12, the Blackbird was designed to be stealthier and more capable, evolving from a bomber concept to a reconnaissance marvel. Unveiled in 1964, it officially joined the ranks of the U.S. Air Force in 1966 and served until its politically charged retirement in 1989, only to be briefly resurrected in the 1990s before its final retirement. Equipped with advanced sensors, radar, and cameras, the SR-71 was unmatched in its time. Operating at altitudes of 85,000 feet and speeds up to Mach 3.2, it was able to outrun any missile launched in its direction, literally speeding up to evade threats. But as the world moved towards satellites and unmanned aerial vehicles, UAVs for reconnaissance, the Blackbird's days were numbered. Despite its retirement, the SR-71 remains the fastest air-breathing manned aircraft, a record set in 1976 that still stands as of 2024. But the story doesn't end there. Lockheed Martin is developing the SR-72, a UAV expected to take flight in 2025. As we edge closer to the debut of this successor, let's rewind and explore the legendary capabilities that made the SR-71 Blackbird a game-changer for the U.S. Air Force. Before the SR-71, there was the U-2, another Lockheed-built reconnaissance aircraft. While the U-2 was effective, it was relatively slow, prompting the CIA to seek something faster and less detectable. Enter Project Archangel, led by the legendary Kelly Johnson at Lockheed's Skunk Works in Burbank, California. Starting in 1958, the team drafted 11 designs over 10 months, with the A-10 leading the way, until it was found too easy to detect by radar. In March 1959, a redesign reduced the aircraft's radar cross-section by 90%, and by February 1960, the CIA had approved a $96 million contract for Lockheed to build 12 of these new spy planes, named the A-12. The urgency for a faster reconnaissance aircraft became undeniable when Francis Gary Powers' U-2 was shot down in 1960. The SR-71 Blackbird. The Blackbird's roots trace back to the pre-1962 bomber series, following in the footsteps of the experimental XB-70 Valkyrie. At one point, the Blackbird's bomber variant was designated the B-71, a name that lingered even as its role shifted to strategic reconnaissance. As the B-70 was adapted for a reconnaissance strike role, earning the designation RS-70, the superior performance of the A-12, a predecessor to the SR-71, caught the eye of the U.S. Air Force. By December 1962, Lockheed was commissioned to create a variant of the A-12, initially called the R-12. This new model was longer, heavier, and featured a two-seat cockpit, more fuel capacity, and advanced surveillance equipment. While the CIA's A-12 operated in the shadows, the SR-71 was destined for overt missions, proudly bearing U.S. Air Force markings. But the story took a political twist in 1964. During the presidential campaign, Republican nominee Barry Goldwater accused President Lyndon B. Johnson of falling behind the Soviets in weapons development. In a bold move to silence his critics, Johnson revealed the existence of the YF-12A, a USAF interceptor that served as a cover for both the secretive A-12 and the SR-71. In a fascinating turn of events, USAF Chief of Staff General Curtis LeMay lobbied to change the aircraft's designation from RS-71 to SR-71, a switch that was reportedly miscommunicated in the press, leading to the myth that President Johnson had misspoken. The SR-71's legend only grew from there. Despite Secretary of Defense Robert McNamara canceling the F-12 program and ordering the destruction of its specialized tooling, 32 Blackbirds were built, 29 SR-71, A's 2 SR-71Bs, and 1 SR-71C. This aircraft quickly became a symbol of cutting-edge aerospace engineering, designed for blistering speeds that reached over Mach 3. With a two-man crew, one pilot and one reconnaissance systems officer, the SR-71 was an early example of stealth design, minimizing its radar cross-section with its sleek, dark blue, almost black color that earned it the nickname Blackbird. This wasn't just for show. The dark paint helped dissipate internal heat and blend the aircraft into the night sky. But the SR-71's real defense was its unmatched speed and altitude. Flying at over 85,000 feet, the Blackbird was nearly untouchable. Enemy radar systems struggled to lock on, and even if they did, the SR-71 could simply outrun any missile fired at it. No SR-71 was ever shot down, a testament to its incredible design and capabilities. What made the SR-71 so special wasn't just its speed, but how it was built. Most aircraft of the time used titanium sparingly, due to its cost, but the SR-71 was made of 85% titanium, with the rest crafted from advanced polymer composites. Lockheed's Skunk Works had to innovate constantly, facing challenges like titanium corrosion from chlorine in tap water and cadmium in tools. Even sourcing titanium was a challenge. Ironically, much of it came from the Soviet Union during the Cold War. These high-speed flights generated extreme heat, requiring unique design solutions such as corrugated wing surfaces that expanded with the heat, preventing the aircraft from splitting or warping. The mystery of its successor. The Blackbird's design echoed the past with a concept similar to the 1920s Ford Trimotor's corrugated aluminum skin, but it was far from antiquated. The SR-71's fuselage panels, crafted with loose-fitting tolerances, only aligned correctly after the aircraft reached the extreme temperatures of flight. This thermal expansion was crucial for its high-speed performance, but created a headache for ground crews who had to deal with the plane's constant fuel leakage. And it wasn't just the fuselage that faced the heat. The outer windscreen, made of quartz and ultrasonically fused to the titanium frame, could reach scorching temperatures of 600 degrees Fahrenheit during missions, with the canopy itself often exceeding 572 degrees Fahrenheit upon landing. Despite these challenges, the Blackbird's design was revolutionary, with features like red lines on the wings, marking fragile areas supported only by widely spaced ribs. Even the tires of the SR-71 were special, made by B.F. Goodrich with aluminum and inflated with nitrogen to handle the high landing speeds over 170 knots. These $2,300 tires needed replacement after just 20 missions, a small price to pay for the aircraft's unmatched capabilities. But perhaps the most incredible aspect of the SR-71's construction was where its titanium came from. Ironically, much of it was sourced from the Soviet Union, the very nation the Blackbird was built to spy on. Through a network of third-world countries and fake companies, the US managed to secure the ore needed to build one of its most secretive and advanced aircraft. The SR-71 was a marvel of stealth design as well, with engineers adding chines, sharp edges extending from the nose along the fuselage, and canting the vertical control surfaces inward to reduce radar cross-section. Special radar-absorbing materials were used in sawtooth-shaped sections of the skin, and carbon-based fuel additives helped to minimize the visibility of exhaust plumes, though the plumes remained noticeable. The development of these chines marked a significant shift in the aircraft's design, allowing for enhanced lift and stability, reducing drag, and enabling the Blackbird to carry more fuel and payloads at high speeds. This innovation also allowed the aircraft to land at lower speeds, a crucial factor in its operational effectiveness. While the SR-71 Blackbird is well known among aviation experts and military enthusiasts, its successor, the SR-72, remains shrouded in mystery. Dubbed the Son of Blackbird, this hypersonic unmanned aerial vehicle is expected to take flight in 2025, but will it live up to the legacy of its predecessor? First whispered about in 2007, the SR-72 is being developed by Lockheed Martin to reach speeds of Mach 6, over 4,000 mph, pushing the boundaries of what's possible in both speed and stealth. When Aviation Week and Space Technology officially revealed Lockheed's work on the SR-72 in 2013, the public interest was so intense that it overwhelmed their servers, a testament to the aircraft's potential impact. The SR-72 aims to be more than just a faster Blackbird. It's designed to be a game-changer in military strategy. Lockheed Martin's program manager, Brad Leland, has highlighted the significance of this speed, revealing that hypersonic aircraft, coupled with hypersonic missiles, could penetrate denied airspace and strike almost any location across a continent in less than an hour. This capability, if realized, would revolutionize military operations much like stealth technology did decades ago. The SR-72's development involves cutting-edge advancements, including a new hypersonic propulsion system that could allow it to accelerate from a standstill to Mach 6 with the same engine, doubling the speed of the SR-71. Achieving such speeds requires a complex engine design, and Lockheed Martin has teamed up with Aerojet Rocketdyne to develop it. The SR-72's engine will likely combine turbine and scramjet technologies, utilizing a shared inlet and nozzle but separate airflow paths to handle the transition from subsonic to hypersonic speeds. Flying at Mach 6 creates extreme heat, necessitating the use of advanced composite materials like carbon, ceramic, and metal mixes, which were previously used in missiles and the space shuttle. The quest for hypersonic capabilities is heating up, especially as global tensions rise and major world powers, including the USAF and PLAAF, race to develop their next-generation fighter and bomber programs. Hypersonic Dominance. By 2017, the SR-72 was no longer just a concept. It was shaping up to be the most advanced intelligence and strike platform ever conceived. But here's the kicker. Existing payloads were woefully inadequate for what the SR-72 was poised to achieve. This hypersonic titan, envisioned to soar at unprecedented speeds and altitudes, needed an entirely new arsenal of sensors and weapons. The challenge? Developing them in time for a planned scale demonstrator, roughly the size of an F-22 Raptor, with flight tests scheduled to follow. Imagine this. A 100-foot-long beast designed to be the next evolutionary step in air dominance, potentially entering service by 2030. The Air Force had set its sights on achieving hypersonic strike and reconnaissance capabilities, and the SR-72 seemed like the perfect fit. Yet, Despite the Air Force's clear interest in hypersonic technology, the funding for the SR-72 remained elusive. Budget constraints reared their ugly head, forcing the Air Force to pivot toward developing the Northrop Grumman RQ-180 stealth UAV for reconnaissance missions, a cheaper and faster alternative. But that didn't spell the end for the SR-72. In December 2014, NASA stepped in, awarding Lockheed Martin a contract to explore the feasibility of building the SR-72's engine using existing turbine technology. This $800,000 contract wasn't just any ordinary deal. It was a study to see if a turbine-based combined cycle (TBCC) propulsion system, which merges a turbine engine with a low-speed dual-mode ramjet, was even possible. Lockheed had previously discovered that speeds up to Mach 7 could be reached by combining turbine and ramjet technology. But the real challenge lay in bridging the gap between a turbojet's top speed of Mach 2.2 and a scramjet's starting speed of Mach 4. The study explored the potential of modifying existing jet engines to handle this critical transition phase. If successful, NASA would move forward with funding a test vehicle for the dual-mode ramjet. The stakes were high, but so was the potential payoff: hypersonic speeds that would make the SR-72 untouchable. To bolster the effort, NASA also awarded Aerojet Rocketdyne a contract to assist with the development of this groundbreaking propulsion system. Are we ready? In March 2016, Lockheed Martin's CEO made a bold claim. A breakthrough was imminent, one that would enable their SR-72 hypersonic plane to shatter the skies at Mach 6. The audacity of this statement was matched by the suggestion that a demonstrator as large as an F-22 could be built for under $1 billion. Fast forward to June 2017, and Lockheed Martin was more determined than ever, announcing plans to develop the SR-72 by the early 2020s. They weren't just dreaming. They said the technology was ready, and they were already working with DARPA to make it a reality. By January 2018, the hype around the SR-72 only grew stronger. Lockheed's vice president highlighted how advancements in 3D printing and computer modeling had turned the impossible into the inevitable. Just a month later, another Lockheed executive clarified that while no SR-72 had yet taken shape, hypersonic research was making strides toward reusable vehicles, a game-changer in modern warfare. By November 2018, Lockheed stated with confidence that an SR-72 prototype was expected to fly by 2025, armed with hypersonic missiles and ready to enter service in the 2030s. But it's not just about speed. Complementing the SR-72's hypersonic prowess is the laser weapon system, or LAWS, a terrifyingly precise instrument of destruction. This isn't your grandfather's defense system. LAWS is the cutting edge, a beam of pure energy capable of obliterating targets with shocking precision. Traditional weapons are left in the dust when faced with the speed and accuracy of light-based weaponry. LAWS works by focusing a high-energy laser beam onto its target, where the energy is absorbed, causing catastrophic damage or outright destruction. Imagine incoming threats like missiles or enemy aircraft being melted or disabled mid-flight. LAWS makes that a reality. Yet, the SR-72 might not have the skies all to itself. Some experts believe the only aircraft capable of challenging this hypersonic marvel is another U.S. creation, the Next Generation Air Dominance, NGAD fighter. Initiated in 2014, with an estimated $16 billion price tag, the NGAD program is operated by the U.S. Air Force and represents the pinnacle of sixth-generation fighter technology. With speeds over 1,800 miles per hour, a flight ceiling of 15 miles, and a stealth coating designed to slip past radar detection, this aircraft is a force to be reckoned with. But what truly sets the NGAD apart is its artificial intelligence system, allowing it to control a swarm of drones mid-flight. Among these drones are reconnaissance units equipped with ultra-precise radars capable of tracking any movement within a 46 square mile radius. Together, The hypersonic SR-72 and the advanced NGAD fighter signal a future for the US Air Force that's more promising and more terrifying than ever before. Thanks for watching. While you're here, click the link on your screen to check out another of our deep dives into the cutting edge of military technology. See you there.